Hello, today, I would like to give a presentation on the good, bad, and unexpected ugly when using AI in online diagnosis. In dermatology, there are already numerous AIs. Today, I will discuss model dermatology, which is our multi-class algorithm. The algorithm can be freely tested on a mobile phone or PC through internet browsers. The primary goal of the app's development is to provide appropriate skin disorder information to people worldwide. There are two main modes. The first mode, the wiki mode, allows users to click on a disease of interest from the disease list to obtain information along with relevant photographic details. The second mode, the image search mode, analyzes pictures taken with smartphones. This mode provides a list of potential disorders. The app was developed from the outset considering multilingual support, including Korean, Italian, and other languages. The app can analyze images and list possible conditions such as hemangioma and nevi. Additionally, by assessing the risk, we can recommend dermatologists for cases with a high risk level and general practitioners for those with a lower risk level. The algorithm can analyze up to 186 conditions, enabling it to provide appropriate information for various rashes or infectious conditions. When individuals experience skin issues, they often lack a knowledge of which conditions to search for. The algorithm, however, can offer a relevant list of conditions that should be considered. In a study published in 2018, our AI could classify 12 tumorous disorders at the level of dermatologists. A similar approach was applied to general disorders, and validation was conducted for 134 conditions. In the task where diseases were diagnosed, based on photos alone, AI performed at a similar level to dermatology residents. At that time, based on these results, it seemed like AI could potentially replace dermatologists. However, there were several issues. The major problem was that these results were obtained from curated datasets in an experimental setting. The test was conducted like a quiz using these photos in this presentation. Additionally, the test was limited to clearly diagnosed disorders. This research demonstrated the difference between attending dermatologists and dermatologists in an experimental test. This is a graph for distinguishing malignancy among 43 tumors from a tertiary hospital in Korea. The red line represents the performance of the attending dermatologists, while the black line represents the performance of the dermatologists in the experimental test. We can see that there is a significant difference, of more than 20% in sensitivity, at the same specificity. In other words, while AI performed better than the physicians in the experimental setting, it is still difficult for AI to outperform actual physicians who have additional information for diagnosis. In 2022, there was a consumer report on online diagnostic apps by a German consumer organization called Stiftung Warentest, a semi-governmental institution in Germany. The report compared 7 apps, with 6 being telemedicine services provided by dermatologists and 1 being our algorithm. In the overall score, the algorithm ranked 6th. Most apps received a score of about 3.0. The algorithm received 3.4, and 1 telemedicine service received the lowest rating. One of the evaluation criteria was diagnostic accuracy, where the algorithm slightly fell behind. Considering that other services are paid services provided by dermatologists and take 1 to 2 days to diagnose, the performance of the algorithm is encouraging. There are several issues currently impacting the performance of AI. These include out of distribution, OOD, Clever Hans bias, irregular composition, and inadequate photographs. OOD refers to the model incorrectly classifying all instances of unseen problems. Clever Hans type bias occurs when the model learns from incorrect features. Additionally, the quality of image have a significant impact on the model unlike humans. To overcome these issues, it is important to provide clear instructions to users submitting photos. From a model development perspective, training a single large model using clean data is crucial. Let's examine these issues one by one. For OOD, let's consider the example of a model trained on dinosaur species. If I input a photo of myself, it incorrectly identifies me as a velociraptor. In dermatology, a model trained solely on melanoma and nevi images may show unexpected wrong outcomes if we input basal cell carcinoma. Clever Hans type bias is another important and difficult issue. If a model is trained to recognize wolves, based on many images with snow, it might associate the presence of snow, rather than focusing on the actual appearance of a wolf. The algorithm may learn from the incorrect feature. This bias can also occur in dermatology, when certain malignant lesions have more markings, leading the AI to associate those markings with malignancy. ImageNet is a well-known dataset for machine learning. In ImageNet, there are well-organized objects. However, in real-world scenarios, such as the ObjectNet, the images are more diverse, and not as neatly composed. State-of-the-art algorithms, even those achieving high accuracy on ImageNet, struggle to perform well on ObjectNet, just after the composition is changed. The same problem applies to dermatology, and it is unlikely to achieve accurate diagnosis, using poorly composed images, with subpar focus. In summary, the algorithm was more accurate than internet searching of laypersons. The performance was better than general physicians. However, the limited information made it challenging to achieve accurate diagnoses. The diagnostic ability of some conditions was limited. As an unexpected outcome, AI was vulnerable to inadequate images. Thank you for listening.